Howdy folks, welcome back. Let me do just a slight adjustment here. That's good enough. Oh boy, do we have a ton of revelations. So, those of you who are keeping your lists like good boys and girls, well, we're going to fill in the middle and we got to add on to the end, alright? I want you guys on your taking notes, on your best here. Pay attention because this is going to get deep. We're going to go into a realm of physics that, well, let's just say we're going deep tonight. So what else did I find? You're about to find out. So hopefully you have your list. We're going to fill in 13 to wherever you have room, and then from 16 or so on down, we're going to 13, 14, 15. Then I get 16, 17, 18, 19. I've figured out up to 19. We're 19. Yeah, we got a lot to cover tonight. All right, you guys. So this is very important. All right. This is not a joke. I'm not trying to scare you. This is research, okay? And I'm going to tell you what I found and what you guys need to look for next. So, kind of stalling, giving you time to get your papers and your pens and your lists and your drinks and your snacks. Because class is in session. So, what I wanted to start with first was not this. That will be a reference for later, especially this reading right here. Okay. So what I'm going to do is start back here. Here's our event. Okay, you guys. This is the February 18th event right here. Okay, this is a huge event. Okay, and I don't believe that detector saying this is a C class, because this is way more, and I'm going to show you as soon as I get my light adjusted. Oh God. All right, where do I want to start off first? So we had missing data. All right, so I went to no. I went to over here and loaded up everything for us. So where to start first? Lord help me, where do we start first? First, we'll start with 13. Number 13, we got to write down. Number 13 on your list is going to be mirror image, okay? Or mirror portrait, either way. Mirror portrait or mirror image, because that's what we're seeing are mirror images of results that we've seen on other planets, right? That's how we started our list, was effects on other planets that we're already seeing, okay? So 13 is the mirror image. All this list is a mirror image of what we're seeing in other planets and what we're seeing in the sun and what we're seeing in the earth. So ta-da, 13 will be mirror image. Oh boy. Now, as we go further in, I showed you the videos of how magnets can create a vortex, all right? I knew there was something wrong with this hurricane because it is so intense, and these readings, okay? That's what kind of attracted me. I was wrong about how the instrument displays them, but what I wasn't wrong about was a lot of the physics that's going on here. This is a geomagnetic storm, okay? So, whoops, I didn't even give that that's new. So, we got to add that. Geomagnetic storm is going to be 14 or sub part of 14, okay? Because 14 is going to be magnetically driven vortex. So write 14 as magnetically driven vortex, and then what was I just saying? Oh gosh. Okay. So, oh boy, dang it! I didn't write it down fast enough. Hopefully, one of you guys did. So, I lost my train of thought. I got so many notes and so much going through my head. It's hard to do this when you're in excruciating pain. Now back. Magnetic driven vortex. What about it, Brian? We were seeing mirror images of magnetic vortexes. Okay, so, dang it. What was I getting to? Well, I'll get back to it. Anyways, let me blow this up and show you some missing data that we were missing. Here. Well, we go tighter, I guess. How's it looking on the screen? I gotta remember, guys, and the screen, okay? Because you guys need to see the stuff clearly. So, I was able to come over here. Is 200 too much? Yes, it is. Please, Lord, give me patience. 150. Duly noted. 150 is our max about there. Yeah. Okay, let me center it. Here we are. 218. Okay. Let's back up and look at a few events that led up to this. Okay, so I have backed up to 216 here. All right, and we've had these events that were preceding today's event. Okay, boom, boom, boom. At least I can go back in my replay and see it in the replay what point I was trying to make back with the notes. So, as we're progressing here, we've had, come on now, into the 17th, okay, here we go. Here's a little activity right here. This is one I reported on. Oops. Come on, Lord. So there's that one. Continue. All right, there's this one that we reported on, okay? You can see the magnetic field around some small object right here, okay? Report on that. That was on the 17th, okay? The day before, yesterday. Sorry, it was yesterday. Pardon me. The day before our event, and then, boom, here comes our event. Bam. All right. Now, as we back up here, something I want to show you is right around here. Do you notice how it's, whoops, I need good lighting now. Good lighting, it's really not giving the effect I need, but as we go, I want you to notice this area right here get darker. Do you see that? Okay. And then it remains dark. We have that event. It remains dark right here. There's no background stars. Okay, there's no background stars right now. Then we have, boom, our big object, our big event, all right? Still no background stars. There's all kinds of UFOs dancing around this event, all right? We can see this one down here. Wait until I show you other angles here, okay? So, and then after it continues, there's still this dark patch, all right? Okay. Backing up, backing up, backing up to right before it goes dark right in that area, okay? So, this is our kind of beginning of this object moving in. It has its outside orbiting planets or whatever, boom, stellar cores, we're going to call them, because that's what they probably are. Okay, then we have another stellar core right here on an inside orbit. Here's something right there. There. Wow. It's a camera picture capturing that. Mm, mm, mm. Can you see it right in that dark patch right in there? Can you see that circular object in the corner right here? Sorry, I'm holding the thing with my mouth. Right there, okay? There's more going on in here too. Okay, so there's multiple objects in this little blast. These are objects that are outside the main one. Okay. Oh, sorry, I gotta plug back in, all that great stuff, but that had to be done, sorry. Adjustments, not too bad. Center it again. A little too sloppy here. Alright, because this is very important. Okay. So this is right before our object and our dark patch is forming, okay? Then, bam, here's our event, okay? It's all dark back behind there, too. And I'm going to explain why, alright? This is an important event. This is our secondary event that we were looking for. I don't care what their graph says anymore. I know what I'm looking at, alright? Oh, boy. I'm getting enough water. Okay, so now we need to come back over to the list. No. What was I doing next here? Other instruments now. So I need to, boom. Come over to this one. Here's stereo A, you guys. The missing data on stereo A. Look at that. Boom. We have all the frames. Okay, so we're gonna, hold on. Let me zoom in real quick, you guys. I know you can't wait to see. Yeah, I was busy doing homework while I was gone. All right. Here we are at our event. Boom, boom, boom. Just right before, recognize this one. This is the very beginning. We already have a dark patch here from this vantage point already. So here comes our first little object moving through. We have our dark patch. Here comes our second one. There's a UFO right there. Bingo. These things are accompanied with UFO with a bunch of them. All right. It's probably an inhabited planetoid system or something. All right. Now, oh God, can we get this right frame and get it right in the camera too? Oh dear. Let's scooch. What? Okay. What I'm gonna try to point out here. Is right in that frame or this one? Yeah, and I'm not capturing it whatsoever. It's hard to tell. There's a counter up in the corner of my screen. I can't really center this much more. Oh, wait. Here we go. Give me just a sec here. Because I gotta try to... There is a circular object right here. It's really hard to detect, all right? It's hard to see. I can tell by the fluid motion of this how these wrap around, okay? Here's our bigger object. It's back again. And I'm going to show you a different angle of it here. Back in 2017, on September 10th of 2017, this is 13 days before the Revelation 12 sign. Here it is back then when it passed the planet, when it passed the sun. Here's the object. It has this conduit of plasma, a vortex of plasma that it's pulling off of the sun and into it. This has a strong gravitational and magnetic field, so strong it creates number 14 magnetic driven vortexes, okay? Whew. Are you guys getting this? I have to say it nice and slow so you guys can grasp this. It doesn't seem too tough, it's really simple, but we are talking advanced astrophysics. So if you guys are grasping this, you're more intelligent than the average The average Joe. So that is a representation of our object that was caught again right in here. This is the plasma being stretched out. Boy, it is not capturing it at all. Anyways, I'll tell you why. It's hard to capture this object. It is extremely hard to capture this object. So I believe it's right in here. We have other little planetoids coming along, stellar cores coming along with them. Okay, and then it moves out. Now, note our dark patch. This dark patch follows this the whole time, and once it moves out of screen, ooh, what the heck? Okay, that one I still can't explain. That looks like a plasma exchange of some kind, maybe between two objects that are close to the satellite. They may have passed a band, like a magnetic loop that's further out, and it charged these things, and they had a plasma exchange. I can't tell for sure. That one I don't really want to go into. But what I was trying to point out is our dark patch is receding and disappearing. Here's some more little objects coming out, trailing this bigger object. Okay. Okay, now that we've seen that, I'll leave right there for a minute because I want you to understand the shape of this object and how it works, okay? We're going into advanced physics now, astrophysics. This again is a representation of what's going on in that image, all right? This right here, we're going to explain this object tonight, all right? And then we're going to explain a lot more physics, and it'll all start to make sense to you guys, all right? So hold on tight, get your pens and papers out. This object, hopefully you can see right here, this darker region right here is the damage or the impact zone and the damage ring, okay, from this plasma striking it. It's striking this vortex conduit of plasma is striking the surface of this object and spreading out in a circular fashion in all directions. That is the please, Lord. That is this damage ring that we are seeing right here impacting the surface of this bigger object, all right? It looks like it's a loop coming out, a loop of plasma on this side, which that's what tricks NASA. But when you look at the structure, this comes down and spreads out. This is coming down and then spreading out. If you could see, you know what, you need to come over to here and look closely at the flow, because this is not doing it justice because I'm not zooming in. So let's zoom in. Okay, this flow is coming from a central point right here. That's the sun, okay? If you look over on the other side, that white circle represents the size of the sun, and I'm not going to play games. I'm going to just do it. Okay, right here. This white circle represents the size of the sun. Superimpose that white circle right in the middle of this black occulter disk, okay? All these lines are pointing right, they're scooping right into that central spot. Now, back over to my what I was trying to show you. All right, maybe back up one frame. No, next frame. There. See it spreading out on the surface of this bigger round spherical object. Okay, there's the secondary core that's with it. Okay, you see it? See the instruments reacting to it too, all right? Okay, you can see it. This other one is so dark you can't see it, all right? And we're going to get into the physics of that here in just a sec. I just need you to understand the shape and recognize a plasma conduit hitting the surface of another spheroid object and spreading out, creating a damage ring. This is a much bigger example of the damage ring, that I'm talking about, all right? Magnetically driven, too. Boom, okay? So, now we saw the dark patch. We don't see any stars. It's all dark back there because this object is bending and absorbing light. Now, let's leave it on. Boom. This image, I'm going to blow this up so you guys can see it a tad bit better. Okay? I want you to look at that image as we start to go into the list now. We are going to go very deep now. So, 14 was magnetic driven vortex. Now we're getting into this object here. Let me explain this object a little bit better. This object is so big and so dense, it has such a strong gravitational field that it also enjoys, it's so strong that it absorbs and bends light, okay? It's much like a black hole, but it's a stellar core that is so big and so packed. Density is the key. Density doesn't matter what it's made of. Well, it does, but the density of this object, and I'm going to get into that, is the key. So, the density of this object is so great that it absorbs and bends light much like a black hole does, okay? You see it bending the light right here, okay? It's bending over the curvature of this spheroid object, okay? This bending right here, it's trying to absorb this light, but it's so much that it's splashing over this invisible sphere. This sphere does not reflect light. It absorbs light. It's so powerful that light cannot escape from it, so it absorbs light and does not reflect light. But when passing by a star, it rips plasma off that drapes. Are you kidding me? What the? Whoa, 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 whoa. I do not PayPal. I am not honey. Thank you. Whatever. Whew. I'm trying to ruin my train of thought. Hopefully you guys are still with me. So dense, it bends and absorbs light, right? Okay? You guys are absorbing this because I'm getting to another aspect. This also is so big and so dense that it enjoys another attribute called number 15, gravitational lensing. So I want you to write down number 15, gravitational lensing. Gravitational lensing is taking light from behind it and bending it around and putting it on the front and making it appear, what's on the back appear on the front, okay? Making it appear see-through. We use galaxies, which are massive, have a lot of mass, to bend light and see through as a lens to look deeper into space. That is gravitational lensing. And here we have this object doing the same effect. All right? It enjoys both effects of black hole absorbing light, not reflecting, as well as gravitational lensing. Those two attributes are God's perfect stealth, okay? That's why this object is so hard to see. We can detect the core right here in front of it, but we cannot see this object. We can see waves coming off of it, right? We can detect the waves, and maybe that's where Michael is talking about waves. The waves coming off of this is what they're detecting. They aren't sure. They can't see this big object because it doesn't reflect light. It doesn't emit light. It doesn't emit infrared. It doesn't emit anything. All it does is suck in more protons because it's super depleted. It's a stellar core that blew up, and all the material went ripping away at the speed of light, so much that it changed this into a different phase. It is super depleted of protons and electrons. Now, density comes in when you squeeze down so hard. Imagine you took all the mass in our solar system, the sun, every planet, every asteroid, you squeezed it down to the size of a BB. All right, a little copper BB. Imagine how dense that BB would be. That's the phase or state of matter that this object is in. It squeezes down so hard onto the atom and to the molecule that there's no longer room for the electron to travel around the nucleus, squeezing out the electron. When you squeeze out the electron, the other charge, the proton, the opposite charge, wants to go and leave as well. So both proton and electron leave, leaving just the neutron. Okay, this is like a neutron star. This is a phase of matter that is super depleted, only neutrons, and it's sucking in any kind of energy it can. Anything it goes by, it sucks in the electrons and protons from it. All right? That's what makes it so hard to see and detect. But when it happens like this right next to the sun, boom, this invisible object gets draped like an invisible table with a tablecloth of plasma going over it, painting our target. Ta-da! Whew. Did you guys grasp that? I know it's kind of deep, but it's not really. It's quite simple. God works quite simply. We just try to overthink it, and if you just use the laws and apply them in applied physics, we can get lots of answers. So, Einstein and all you guys, we're going further. I'm trying to think of the other scientist that was in this arena. I can't think of him right now because I'm too busy on this. So, 15 was gravitational lensing, and do you understand why? Now, a side effect that comes with something so dense, so massive, it is easily 5 times bigger than our sun. We cannot go there yet. We have to stop at 15 because I have a different display now. Display time, folks. You guys ready? Actually not display time. We are, definition time. And, we're going to make real astrophysicists out of you guys and not a Hollywood make-believe, wannabe, blah, blah, blah. Okay, so let me come over to... I'm just opening up to one of my references that I highly recommend, but they don't make it anymore because of the valuable information that they accidentally spilled in it. So I'm going to have to remove camera, and I want you guys to follow me. Over here, this is part of our explanation. You see the black hole here. Now I'm going to do the best I can to hold this still. Okay, a super dense point in space formed by a collapsing stellar core more than 5 times the mass of the sun. A black hole's gravity is so powerful that even light cannot escape from it. Okay, now what I want you guys to understand here is a black hole is not like Hollywood taught you. It's not a hole in the fabric of time and space. It is a super dense stellar core with more than 5 times the mass of our sun. It has more than 5 times the mass of our sun. You see the circumference of the sun. You see the circumference of this. This is three-dimensional now. It's a ball. How many suns can you fit inside this ball? How many little balls can you fit in that one? That's how you judge the size, the three-dimensional size of this. You can't just take a circle and another circle and figure out its area and blah, blah, blah. This is three-dimensional. Okay? Now, back here. You guys are grasping this, I can tell by just the silence in the because you're taking notes, I think. So back over here to black hole. So now I want you guys to understand a black hole, not a hole. It's a super dense sphere, a stellar core. That is the burned out stellar core of our binary twin. Most likely. Can't say 100% for sure, but most likely. And there goes the book. So, I'll pull this book back up. Okay, because we're going deeper and deeper and deeper and deeper and deeper into space. Okay? Now, what was the other one I wanted? Black Nebula. Where is Black Nebula? Black. Hang on, guys, real quick. I'm going to set you right there and want you to look at a black hole. They say it's impossible. They say it doesn't exist. They say you can't capture it. Blah, 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 blah. I'm telling you right there is your black hole, okay? It fits a lot of definitions, so we're going to go into it first. So it's also a neutron star. It's made up of neutrons. It's so densely packed that all it is neutrons. It takes in this light and stuff, but it's never enough. It's never enough to refire this core. It would have to encounter a star 100 times its mass in order to reignite. Or maybe it's just going to suck ours dry. It's like a vampire, okay? That's what I like to call it, is a vampire star. Now, while you guys are staring at that thinking of vampires, I'm trying to find, we have red dwarf, we have brown dwarf, but I want, where is it? There's neutrons, dark nebula. Oh, please, bear with me. Oh, there it is. Okay, yay. Now, you guys come with me again. We're coming over here to dark nebula. Okay, a cloud of interstellar gas and dust that absorbs light and is only visible when silhouetted against a cloud of stars or another type of nebula. Okay, the reason why we're here at dark nebula is because definitions matter. Okay, yeah, could you guys stop posting for a second? Just for a second so I can see this. Alright, I'm trying to do this. Okay. A cloud of interstellar gas. Let's simplify this. Gas and dust. Well, gas and dust is matter. So, it doesn't necessarily be in a cloud. We're talking about gas and dust that's matter that absorbs light, okay? Matter that absorbs light and is only visible when silhouetted. Is only visible when silhouetted. Get it? You guys got it? You understand a little bit here? This is silhouetted by the plasma coming off the sun. That's how you see this. It's silhouetted, the plasma coming off the sun. So, we have dark matter, or dark nebula, which is matter, okay? And we have black hole, which, right there. Let's also read brown dwarf. Brown dwarf is a failed star, a ball of gas that never grew big enough to start shining by nuclear fusion, but which still glows dimly in infrared. Now, I don't believe this to be a brown dwarf. This is far from dwarf. This is big. This is far from a dwarf. This is big, okay? It's bigger than our sun. Imagine how big our sun is. I'm sorry I can't answer questions in the chat right now. I'm busy explaining class. You guys can chat amongst each other, but back to over here. My mess. Sorry, I am trying my best. Where were we? Brown dwarf. So, a lot of people will say brown dwarf, but what I will say about this is failed star. Okay? This is a failed star. It's dead. It failed. I believe this one already existed. This says that it never grew big enough. Well, this is way big. So it has obviously grown big enough. It has just gone through its phase. It's not a brown dwarf, though, okay? So that's why I couldn't show you this other stuff. Back to staring at that, thinking about it for a minute. Infrared. I don't know if this thing is emitting infrared. That's what I'd like to know. Maybe that's why NASA can't see this, is because it's not, or it can because it is. Either way. But if it's not emitting, it might not be emitting infrared as well, because that's a spectrum of light and radiation. It might not emit any kind of radiation, okay? Even though it soaks in so much, it doesn't emit any, just like light, okay? All right, what was the one other one we had? Red Giant. Okay, I'm just going to read this one. A star passing through a phase. No, this is not Red Giant. Where was it? There it is. Okay, here we go. We're going to go into this one now. Pulsar. A rapidly spinning neutron star with an intense magnetic field that channels its radiation out along two narrow beams that sweep across the sky. All right, it can also radiation out along its magnetic field lines. Okay? So, a rapidly spinning neutron star with an intense magnetic field. A rapidly rotating neutron star with an intense magnetic field. It fits the definition of quite a few things here. All right, but I think that was all I found for the moment. Oh, let's read neutron star. There it is. Okay. Oh boy. All right, can you stop posting Nine of Diamonds just for a sec, because it's popping up on my screen. Yeah, thank you. Just for a second, then you can go back. I can't read this through my screen. All right, neutron star is the collapsed core of a heavyweight star. Boy, are we talking left behind by a supernova explosion. This thing probably supernovaed, micronovaed, or something, and blew off its plasma shell. A neutron star is the densest known object. What they say? The densest known object. Remember we were talking about density? Neutron star, where were we? Okay. Neutron star. And I want you guys to see these printed, so you're not just taking my word for it. This is deep astrophysics. This book is not made very much anymore. Okay, a neutron star is the densest known object, though in most massive stars, the core can collapse past the neutron star stage into what? A black hole. Many neutron stars are also pulsars. And I read, there's pulsar. That's the one I meant to read earlier. I messed up. A pulsar is a rapidly spinning neutron star with an intense magnetic field. Oh, that is the one, yeah. Okay. You guys getting it? We're back down here, neutron star again. The collapsed core of a heavyweight. And it looks like some of you are still here. Oh, I thought they took me out. Ugh. Which I would not suggest. That would be stupid of you guys to try to take me out right now. Okay? That would only prove how guilty you are. So, hold that thought, you guys. Now, back to while they're rebooting my computer. Wow, really? Freeze this. Hang on. I gotta freeze this. Oh well. Neutron star, guys. Alright, back to where we were. The collapsed core of a heavyweight star. You saw it. It's left over by a supernova explosion. Okay? It went nova and it shed its shell. Okay? You're just looking at the core that's left over. Except that core happens to be... Come on, you turkeys. I'm going to get this video back up there, whether... Alright. So, sorry, I'm talking to the computer while I'm trying to talk to you guys. Nova, a binary star system in which a white dwarf is pulling material away from a companion star. Wow. A binary star, which it doesn't necessarily have to be white dwarf, okay? Well, where'd it go? Alright, a binary star system in which the other is pulling material away from a companion star, building up a layer of gas around itself, and that then burns away in a violent nuclear explosion. Okay? But this part right here, the binary star system, we'll scratch out white. We're probably the white dwarf, all right? Binary star system in which the other object is pulling material away from a companion star. What? Pulling material away from a companion star? Let me get this image back up here in just a second. Right there is that image until I get it up. Is that pulling energy away from its companion star? Okay. I think you guys are getting a picture here. Now, if it would just give me wake up call. Let me get you back in the tripod here. And I've got to type for a second. Thank you for your patience and tolerance with me. I'm doing the best I can, and I think you guys can tell. So I appreciate your patience and hanging in there. 38 viewers at 2 in the morning, so you guys are troopers. You must really want it bad. That's what God likes. He wants you to want to learn. He wants you to want to know. Back to wake up call. Oh, enter. My bad. There we go. And back to our image right here. Boom. Okay. And right before this stellar core was captured, the one in front of it, Nibiru. Okay, this is the one they call Nibiru. It's a black stellar core. It has plasma all the way around it and draping over the front of it. It has these plasma type wings come off of it. I've showed you this video before. So this is the stellar core that's out in front of the bigger one, all right? Just like we saw today on the 18th. Other cores out in front of the big one, and the ones trailing behind it. The 18th, today is the day. Today was the day. That was our event. That was the secondary event that I was waiting for. Is that big one that we saw. Now, back to astrophysics. You guys, I got this pulled back up. So, but isn't that a killer shot? Let me zoom in on this. You guys wanted to see Nibiru so bad? Really? You wanted to see it so bad? Well, ta-da, there it is. And it's not good news, really. I don't know why you guys wanted to see it so bad, because it's real. And there it is. And it comes with a companion, the destroyer. Okay? Let me go right here, Lord. Oh, we have to unzoom to play. Right there. It's good enough. That's about as tight in as I can get. Now you can see Nibiru right out in front here. It almost looks red in this image, but it might be, I think it's black. You know, this is just the red tint of this camera. Okay. Now that I got that up on the screen again, we're going back to definitions. No, that was about it, because I covered a couple of other things that I wasn't expecting. All right, close up the book. So now back to the list. I know it's probably boring, but I want you guys to be able to wrap your head around this stuff. So we have this big bad boy right here that fits the definition of a black hole slash neutron star gone black hole. Okay. Now this is where we go kind of crazy. And where was the other one? All right. So underneath 15, gravitational lensing, I want you to put number 16 is going to be another side effect that we're going to look for now is time distortion, you guys. This thing has so much gravity that it not only bends light, but it can also bend time and give time distortions. Time distortions are a weird thing, and they're hard to describe because it gets into relativity, and you can't detect them if you're inside the bubble of relativity. You have to be outside the bubble of relativity to observe the. You have to have a different vantage point, a different perspective. So, but we are looking at something that could possibly cause some time distortion as well. Okay, now 17, what the heck was 17? I wrote it and I can't even see what I wrote. So packed full of notes. Okay. 17 really doesn't belong on the list, but it's a side effect that I want you guys to look for. Because of all of this neutron star activity reaching out for protons and electrons, you guys look for batteries draining, your batteries in your cars. If you have problems in your cars or batteries draining in your phones for weird reasons, all kinds of batteries are going to drain when this thing passes by, okay? It likes to suck protons and electrons out of anything it can. So when it passes by the Earth, it's going to disrupt the batteries and drain some batteries, okay? 17 was that, but I have that's a side effect. It doesn't really. It can go on the list, whatever. 18 is neutron star. Okay, 16 is time distortion. 17 will be batteries draining. 18 is neutron star, and 19 is black hole. Okay, those are the list. And then where was the middle? Didn't we finish in the middle with 13 and 14 and 15? So the bottom after 17. Okay, so you got 16 and 17 on there. It should be as oscillating magnetic field and new central magnetic pole will create new field lines. So after those goes the neutron star underneath that, and then black hole underneath that. Okay. Whew. So 16. Let me do this again. Oh my God, my notes are atrocious. I have to consolidate this. 16 again was or 16 or 17, right around there. It was oscillating magnetic field. Oscillating magnetic field causing vortexes. Okay, then 17 would be the new. Yeah, that's why 17 wasn't the side effect. 17 is the new central magnetic pole creates new field lines. Okay. Then below that was 17 comes 18, which is neutron star, and 19, which is black hole. Okay? Whew. Thank you, God. Give me the tolerance and patience to do this. And thank you guys for your patience and understanding in trying to follow this, because this is not easy. Now that we're at black hole, we need to start going into even more. Oh, why is my battery dying? No, 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 no. What? Get in there. All right, hang on. My battery was dying there. I'm trying to recover it. All right, because I'm gonna do more. If you guys are staying up late with me, I can see why. Where did my pointer just go now? I dropped it. Rescue and other stuff. So, that's a lot to absorb there, folks. So, think about it. I think we're looking at a neutron star slash black hole slash stellar core slash binary twin that went supernova, has stellar cores around it. It's its own star, so it has its own little solar system, right? So you're looking at a small solar system right here, okay, with a neutron star black hole type at the center. This object has so much mass, it has more mass than our entire solar system. The sun, being the biggest object, has the most mass. The rest of our planets are nothing compared to the sun, right? So they're just a mouse fart added to a big old object. This thing has way more than all of our solar system put together. This might not be rotating around us. We might be rotating around it. After all, it's a black hole, right? Maybe we're rotating around it, getting closer and closer with each pass. Okay, understanding that? Now we're going into dark matter, you guys. We have just proven dark matter, okay? Dark matter is not what the scientists think. It's not a atom, it's not a quark, it's not a molecule. It's actually quite the opposite end of the spectrum. It is a bunch of mass squeezed down so tight that it jumps into that neutron star phase and goes black hole, that you cannot see or detect. You can only see it when it's silhouetted. Bravo. Okay, so when it's not silhouetted, okay, there are ways of detecting it when it's not silhouetted. Now I want you to like flip the coin over and think on the other side looking back. What happens when this is in the vicinity? We get where to go. Missing light, okay? And I want you to write down number 20 as missing light. See here, our event, when this happened, see how dark it got? Because when this object rolls through, it's taking all the light in the vicinity and sucking it in. All right? Here's a core out in front of it. Then notice this patch gets dark as our big object moves in. Where the heck did it go? Did they just reset this on me? No, right here. Okay? So notice right before this, it's a little brighter in this vicinity. Well, we're not getting a very good shot of it. Here's our first little blast. There's our big one. And it's followed by all this darkness right there. On the other instrument, there are no stars in the background. Right here. From right about here, moving forward, there are no stars. All the other ones dancing around is all UFO activity, you guys. I zoomed in on them. It's all UFO activity. They're all surrounding these objects, this solar system that's coming by our sun, okay? Our binary twin has occupants with it, okay? Probably the Anunnaki or whatever that were described back then, but they're not God. They're just Anunnaki. They're probably going to try to tell you that they created you and keep you enslaved so they can get their gold. All they do is want their gold for their planet. So, sorry, we'll go into that another night. But, anyways, here's your dark patch. No stars, basically, because it's sucking all the light in. If there were stars, you would see right through the object, and it would appear stars right in the background. Okay? Because it enjoys gravitational lensing. Now, we have the dark streak. That's a side effect, okay, that we look for. That goes on the notes, just around dark matter or whatever. Then missing light, dark streaks, and then something I'm going to tell you guys about and how to see this object yourself with your own eyes when it passes, okay? Last time when this passed, I was working on these formulas and I knew kind of what to look for and I observed it. And it's a real phenomenon, but nobody believes it. So, now that we've gotten all the way to the end of this, not the end of this list, but very, very deep into it, when we have something that's absorbing light and absorbing protons and electrons passing by us, you're not going to see it because it doesn't reflect light. There's missing light, right? So you're going to look for missing light. Well, what would missing light look like? It looks like a dark patch in the sky. Now, you have to have polarized lenses to see this. Get it? Polarized lenses on your sunglasses. But when this thing passes, I want you to look up at the blue sky with your polarized lenses on. And I want you to rotate your head around the sky, up and down, look around, and you will see a dark patch in the sky. It's a darker blue. It's missing light. There's still some light there that reflects off of ambient light in the atmosphere. So it's not like a black hole in the sky, but it is a darker patch of blue. And when you move your head around with your sunglasses on, you will see it has a circular shape. Okay? And when I detect it, I will point out what quadrant of the sky to look for your dark patch. Okay? That will prove everything right there. Well, I've already proved everything. But I'm telling you side effects to look out for now. We're past proving stuff. We're looking at side effects to look out for now. Done been there and proved that. Dark patch in the sky, dark streaks, batteries draining, brownouts, power outage. Oh, power outage. When this thing passes, it will be the 21st, around there, because it came on the 18th. It takes 3 days usually. God likes to work in 3 days, so I would be expecting this on the 21st. So now we have a new date, and I'm sure it will align with Mike's dates here pretty soon. He'll probably start talking about February 21st. When this thing interacts with our magnetic field going by us, the CME that's coming with this, well, I need to check that. That's what we need to check. Thank you, thank you, thank you, thank you, God. Let's go. CME tracker. Come on, please be updated, please. Run, 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 run. It will not run, but I am going to zoom in on the images that it is giving us at this moment. Because this is not a joke, guys. Look at these pardon my French. Alright, here's Earth, here's the sun, here's our CME hitting right now, and this instrument froze up on this image because the electromagnetic field just got disrupted and computers are reacting. Bingo! That's why it won't play. But you can see the shockwave. This isn't the one this isn't the one from this CME. This is one from 3 days ago. Okay, that I told you would be coming on the 18th. Bingo! And it hit With the other event, the big object I just showed you was our secondary event, the big event that we were looking for. So everything is lining up, and we have a new date. Okay? Whoops. We have a new date. 3 days from the 18th puts us at February 21st. You guys got that? You guys understand why I picked that date? I don't pick that date. It's just in the stars. I want you guys to start preparing. Hold on tight for when this thing passes. This thing came off of region. Ooh, what region did it come off of? Let's zoom out here. You know why maybe that's not working? It's not up, but it might be zoomed in too. You guys still following me? Or am I boring you guys? This image as well. We are frozen up on all three of these images, okay? Boom. This is just the one from the 17th, and it froze this up with this shock wave right here. Here's impact, okay? We're under impact right now. Or it has been for a while since this thing froze up. Oh, boy. Oh, boy. Okay, thank you for your patience here. We're moving along. What else do I need? Auroras, guys, that was on the list. Okay, we're seeing more auroras. We saw slowing of storms. All those side effects I'm not too worried about right now. I'm more concerned about the electromagnetic exchange we might have with this bad boy. And that would be whatever number, I don't know right now, but electromagnetic discharge. I want you to put next to electromagnetic discharge, or I don't know the number, electromagnetic exchange, a conduit plasma exchange like this if we get too close, okay? And the vortex, the gravitational field of this object is creating vortexes. Here's our vortex. This is lined up with the object on the planet or whatever. So gravitationally, magnetically, this storm is lined up with that object. That object is causing this storm, and it's going to cause it. This thing might even grow bigger and bigger and bigger. And oh my goodness, let's back out of this here. And now we're starting to do a little homework while we're doing this. So did you guys catch all that stuff I said about all the dark matter? It's real. That's it. I discovered dark matter, you guys. Woohoo! Along with you. So we're definitely the elite, and I don't think even Ben and Suspicious Observers knows yet. If he does, he doesn't talk about it or doesn't admit to it. Or I don't think he can take Velikovsky's work and progress on it like I did. Okay? Alright, I'm not trying to brag or nothing. I'm trying to be humble about this. I'm really trying to inform you guys, alright? And I'm using their instrumentation to do it, so. Alright? This is more than just our typhoon, you guys. And if it, I wouldn't be surprised if it's leaving similar signatures like this on some kind of heat chart or whatever, magnetic chart or whatever, that I was mistaking this for. But it still is induced by our bigger object coming in. I call it Nemesis. Here's Nibiru. Here's Nemesis. This is what was foretold in the Bible, okay? It showed up 13 days before the Revelations 12 star alignment. The woman with a crown over her head and the moon at her feet, sun. I think you all know about that one, all right? I've explained it several times. This event is the dragon of Revelation 12. You all saw the woman, but you all missed the dragon. I'm showing you the dragon, okay? Only one person can show you the dragon. Hint, hint. So, you're looking at the dragon. It's a stellar core. It's a black hole. It's our binary twin. It's forecast to come by and do its uh, what's the term I'm looking for? Cyclical. It's cyclical event, okay? And this time, it's not just one pass. It's around. Maybe it's not one pass and it's around. Maybe it's standing still as a point in space, like it said in the definition, and we are going around it like a toilet bowl, tighter and tighter and tighter with each pass. It's not moving. We're moving around it. We're caught in the gravity well of a black hole, you guys, and we're getting closer and closer with each pass. And this latest pass was a lot closer than this one. If we go over here, you can see. Oh, let me back over. Let me get this unzoomed. Here, it looks like it's much closer. All right. I hope that I'm wrong. I pray that I'm wrong. My physics say I'm right. Okay? And I've taken it. This object has helped us learn more. Okay? By the effects of it that we're detecting, we can reach deeper into the physics and find out what's going on. And when we get that image, when I saw that image right here, on this day, my life changed. My life changed in a way that you guys' is changing now. When I grasped what I was looking at, and you guys are grasping what you're looking at, my life changed. All right? It's never been the same since, and I'm sorry I'm changing yours, but it's back, and you guys need to wake up and get ready. Okay? I showed you Jesus getting struck with lightning. I showed you all these signs. I've shown you all this stuff. Saw evidence pointing towards the book of Revelations coming true. Jesus is here. He's here. All right? It's more than just him coming back. He's already here. You're seeing the signs of him here. These are other entities from across this universe and in our solar system coming here to see God at work in the grand finale. Okay? So, I hope you guys enjoyed your list. We filled in a lot. We've added a lot. We've covered a lot, you guys, and I'm proud of you for hanging in there and tolerating this, because this is not easy to do. It's not easy to grasp. I'm telling you what, I'm giving you guys $1 million astrophysics class for free. Okay? Hopefully it's staying charged. So, yeah, I'm trying to teach you guys. I'm trying to be humble about this, you know. I'm trying to help you guys learn so you understand. I'm not trying to be right or whatever or argue. I'm showing you evidence that I have acquired to inform you guys to beware. This is warning, okay? All right, that's it for tonight. I'm glad you guys hung in there. It was a long one, but we did it. I love you all. God bless you all. And until my next video, bye.